Again, thank you to ICTM's Math Monday for elementary teachers. I'm so excited to introduce today our presenter, which is actually a former colleague of mine, Mrs. Lindsey Herlehy. She is a professional development and curriculum specialist with the Illinois Math and Science Academy, which is up near Chicago. So I'm going to turn it over to Lindsey, and I'm so happy that she is going to share her knowledge with us today. Thanks so much, Lindsey.
Sure. Thank you, Kelly. And thanks for having me today. Hello, everyone. Welcome to Context is Critical, K-5 3-act math test, which we will spend a lot of time today going through, well, not a lot, an hour. You may be familiar with my name just because I also serve as the ICTM professional development chair. So you typically get all your emails about professional development hours and CPDUs from me. So if you do have questions about CPDUs in the PD Plus system, I'm happy to help you out with that or help Kelly out with that at the end of this. But I am excited today to get away from PD hours and talk a little bit about K-5 math and specifically 3-act math tests, which when we think about all of the math resources that we have at our disposal is not necessarily one of the newest resources that we have, but it is definitely one of the easiest to use and most well-rounded in terms of what it offers for our students and how rich it is in terms of instructional methods and math pedagogy. So we're going to go through and take a look at 3-act math tests from a variety of different angles today. I have a variety of different resources to share with you, and everything that you see today, I will share the links to the resources, the presentation, the instructional pages for it, student pages, and then of course my contact information if you would like to get in contact after this. I'll make sure that you have that as well. When we think about elementary math in terms of K-5, and 3-act math tests are not just for elementary students, they are scalable to middle school, high school, any grade level in terms of who is studying mathematics. We looks like I got muted too. Okay, what we're looking for elementary students to do primarily is to make sense of story problems, to use numbers flexibly, and we also want them to be proficient in asking questions. And 3-act math tests definitely are able to do all of those things. So we are going to make sure that we can go through and take a look at what these are and see how they really allow students to use inquiry-based learning and mathematical modeling in order to understand mathematics through a variety of different math concepts. So in order to understand 3-act math tests, the best way to do it is to experience one. So if you are seated somewhere where you can quickly grab a piece of paper or a pencil, I recommend that you do that. I'm not going to make you do any high-level math today. I am very well aware that it is 3:30 and it's the month of December, which means that it is the craziest time of year to be an educator. So I'm going to we're going to take it nice and easy. But if you could grab a piece of paper, and we're going to start off with the first act of a 3-act math task. So I'm going to show you a quick video, and I'm going to ask you 2 questions after we watch this video. And I'm going to ask you to respond in the chat. You can jot down what you notice and what you wonder, or you can just kind of keep them up in your head. But those are your 2 things that you're focused on here. What do you notice in the video? And then what does it make you wonder? All right, here we go. All All right, that was pretty quick. We'll play it one more time just in case anybody missed anything. All right, very good. So as promised, the first question that I'm interested in is, what did you notice when you watched that video? Go ahead and you can type it in the chat. What did you notice? Let's start off with what you noticed. I noticed the jar is filled with Skittles. Very good. Some Skittles were in there. Probably have a lot of those left over from your Halloween candy. The jar was filled to the max. That's a great observation. I love that. That's a really good observation. It's completely filled. You notice he had to like tap it down so that he could get that cap on top. It was completely filled, no air on the top. All right. Anything else you noticed? Several bags were opened, but I lost count. Okay, good. The jar is full of Skittles, is extra full. Good. All right, so it's full of Skittles. It's completely full. There's no extra room. There were more than one bag that was used and couldn't count how many bags were used. Very good. All right, well, those were some pretty good observations. And these are typical things that we would expect a K-5 student to say. All three of those noticings, those observations are very common. What are some of the things that you wondered? What questions came to mind when you watched that video? I think Leslie had a question initially that said, I wonder how many Skittles are in the jar. Did anyone agree with that? If we were in the classroom, we would use our hand signals. Does anyone agree with that? Yes. Okay, wondering the same question. Anybody else wonder how many Skittles were in the jar? Why use many small bags instead of a large bag? Well, that's very interesting, right? When we think about efficiency, I don't know. Maybe that's all that there was. Maybe those are the leftover ones from the Halloween bowl that nobody wanted. Maybe we only had the small ones. Who knows? All right, very good. Any other what do you wonder questions? All right. Well, I think typically, we have a couple, typically we see how many Skittles are in the jar. I think how many bags did he use is a common question. Very good. Sometimes, these are children, so they will ask like, what type of Skittles did they use? Since, we have a variety of different, I think there's like tropical Skittles. There's different varieties of Skittles. There's sour Skittles. Why did he choose Skittles? A bunch of different kinds of questions like those that you can't necessarily always answer with mathematics, but they are children, so they will ask questions like that, which is totally fine, but very good. Okay, so we have some information, we have some questions, we have some observations. So as a group, we're going to think of the main question that we want answered about this problem or this video that we saw. Now, if I was a teacher doing this in a classroom, I would do that definitely differently than we were doing it here virtually. Typically what I do is students write out their wonderings, their questions that they ask on sentence strips, and then we organize them to see how many students ask the same question, to see which one is the most popular question. And most often than not, remember having your thinking in teacher mode, that is the question that we're after here. So if we're thinking about what's the main question that we want answered, as you can probably guess, it is the question, how many Skittles are in the jar? All right. So that's the question that we are going to answer here today. looking at that problem. Now, before we do that, we're going to make some estimations because estimations are cheap and easy. Anyone can make an estimation, all right? But before I just like guess a number, I'm going to be smart about it. So take a look at this number line that I have. I'm interested in seeing your estimate. I want to know a low estimate, a too low estimate, meaning a number that is too low. There's no way that there is that few Skittles in that jar. And I want to know a number that is too high. There's no way that there's that many Skittles in that jar. And then I need to know a number that is like your just right estimate. What would be a number then that could make sense as being the number of Skittles in that jar, a just right estimate? Okay, so a too low, a too high, and a just right. All right, and once you have that number, go ahead and throw that into the chat and let's see where we're all at. This is a judgment-free zone. We're all adult educators here, so it's all right. Okay, let's see. What do you think? How many Skittles do you think are in that jar? Five to 500. Okay, good. That's some safe estimating, right? 5. We know there's definitely more than 5, but probably not 500. So maybe just right 40. 456 Skittles. Okay. Leslie, I'm interested to see what your too low and too high were. Low is 20, high is 10,000, so 221. Okay, good. That fits. That's good. Very nice. All right. Low 200, high 600. Okay, 250,000 Skittles. I like it. That's good. You're right. Low 40, high 100. What's your just right then? Let's see. We have a 40, a 456, 221. Some just right numbers. There is no prize if you get this right. There's not like an extra CPDU hour. I'm sorry to say. We do have some standards we have to abide by here. All right, so you have a benchmark here, and we're going to use that. We're going to come back to that because this estimate provides us a really good kind of like standpoint as to whether or not our answer may be reasonable or not. Okay, so we're going to come back to that at the end or as we go through this really. Okay. So that was the end of our first act. We are introduced to a problem and we have an idea of what we want to answer. So in the second act now, in the second part, we are going to figure out, well, what information would we need in order to solve that problem? Okay, so we want to figure out how many Skittles are in that jar. What information would you need in order to solve that problem? Go ahead and throw your comments in the chat. What would be helpful to know in order to figure out how many Skittles are in that jar? How many Skittles are in one bag? All right, very good. That would be very helpful. You're right. Any other information? Try to think like a fourth grader. What might they say? Volume. Okay. Increments are groups of Skittles. Okay, so maybe like a visual of what that looks like. Can I eat them? There you go. You nailed it, Leslie. You got it. Yep, that's exactly what they would ask. How many Skittles are in one bag? How many bags were used? Okay, good. How many Skittles are in a bag? How many bags were used would be helpful to know. Good, very nice. All right, good. So these are very good requests for information. How many bags, how many Skittles are in each bag? Excellent. Well, I have some information to share with you, and some of these questions will be answered, but not all of them. Some of them are questions, some of them are not questions, and some of them are questions, but not questions that can be answered with mathematics. So they're not questions that a mathematician would answer. Can I eat them is a very legitimate question, but it's not a question that we're going to answer with mathematics, which is what our job is here today. Okay, so here's what I have to share with you. These are the bags that were used in this video. All right. So once again, here's this picture. How many bags are you thinking? If you had to estimate how many bags are here, what would you guess? And it's hard when it's two-dimensional, right? But how many bags do you think that is right there? 30, 67. Wow, 60. Okay. I always like doing this because I'll be completely honest with you. So math, obviously, like we all are here because we must enjoy math to some degree altogether. Estimation is not my thing. I am actually really bad at estimating, which I don't enjoy admitting. I'm terrible at estimating. So, I like doing these exercises with other math educators because I find it fascinating to see where everyone's brains are in terms of estimating. Okay. So I see a variety of different answers, and some of you are close. There are 58 bags of Skittles in the jar. That's probably important information I would consider writing down if I were you. Okay, so 58 bags of Skittles. The next piece of information that you asked me for were the number of Skittles in each bag. And here is what that looks like. Okay, I think one of you actually said for a visual. So that's kind of like, I think I hit both of those requests right here, right there with this picture. Okay. So that's how many Skittles were in that one bag right there. Right? Now, you asked me for that information because you must have had like some kind of plan in your head with what you were going to do with that. All right. Now, I'm going to give you a minute or two to go ahead and solve this problem now of trying to figure out how many Skittles were in that jar. Now, go ahead and do that however you would like, whatever method you prefer. I will challenge you as math educators to consider more than one method because we know that our students tend to approach problems in a variety of different ways. So there are lots of ways that you can solve this problem. And then we'll kind of think about how that happened. All right. Now, as you are solving, yep, let's hold off on answers because before we do answers, I want to think about how you solved. Okay. Repeated addition is another option. Yep, absolutely. Very good. Okay, see if you can find two different ways to solve. I'm going to assume most of you are using one way. But if you have any experience with fourth grade mathematics, you may know kind of what the standard is for this one, what it closely aligns to. All right. And then once you have your answer, go ahead and throw into the chat the method that you used, the one or two methods that you use. Maybe the one that you quickly went to, the most efficient, the one you were most comfortable with, and then maybe what your stretch was. What did you give another shot at? Or perhaps if you do this with your students in your classroom, where you may have begun or what you may have expected them to, how you may have expected them to do this problem. Rounding and multiply. Ooh, interesting. Can you tell us more about that? What does that look like? Is there a way to type that into the chat? I feel like I know. My daughter is in third grade and she's doing some rounding and multiplying, and I'm like, wow, this is crazy. Yes. Okay. Got it. Oh, yeah. Yeah, absolutely. You're also welcome to unmute and explain if you're comfortable doing that. I never want to force someone to, but if you'd like to explain, we'd love to hear it. Anyone solve it a different way? Okay. Well, typically when we do this, we see when we do this PD in person, we typically draw out our solutions on big chart paper and we compare different ways that students are able to solve this problem. Usually we see the, de facto method is partial products, which is very typical, especially for those of us that grew up in the traditional style of mathematics. Okay, 50 plus 8 times 10 plus 4. Yep, absolutely. Very good. And then we can also see, though, when we are encouraged to use other strategies, teachers will use the area models, they'll use arrays, they will break it apart, just like Olivia did right here. Very nice. So there are lots of different ways to have students do this, and we love giving them the opportunity to solve it in a variety of different ways. And encouraging them to use more than one method without necessarily telling them, here are all the choices that you have, is always a great option as well. So lots of different ways. Now, what did you get as your answer is my final request here. What did we end with? 812. Anyone else agree, disagree? Ditto. Very nice. 812, 812. All right. So I see some very familiar answers. All right. Very good. Okay. Now, as we continue on, when you're doing this with students, it's important to remember that that's not necessarily where this problem ends. So a lot of times when we're in class, and it's not necessarily just because it's like, there's a lot of factors that play into the way that lessons end, right? And a lot of times it's because of the lack of time. But arriving at a solution to a mathematical problem isn't the end. It's the opportunity to think about the reasonableness of an answer and what comes next. So additional questions that we have based on the experience that we just had. Okay. So when we think about looking at the third piece of this, the third act of the 3-act math task, you all said 812. And before I play this video, I want you to think back, and you don't need to tell me how this worked out for you, but we did estimating back during Act 1, and you created benchmarks that said, what is a too low number and what's a too high number? And what I'm going to ask you is your final answer within your benchmark? Because if it's not, one of two things is wrong. Either your estimation model is incorrect, or we don't trust your mathematics of figuring out the number of Skittles. And with your examples, for many of you, your estimation scale was so wide that your number probably does fall between those. For some of yours, it was actually probably pretty tight. And I'm not even sure your answer fell in there. So both of those things may have also been wrong. But that's an interesting question to have your students think about. We always want to drive students back to relating answers to their estimations. And that's how we train students to think, is my answer reasonable? And we'll revisit this thought when we go back and take a look at each of the pieces of a 3-act task, because it needs to be reiterated over and over and over again how important it is to make estimates. But let's go ahead and see how this turns out for us. All right, so here's the third act of the 3-act task. Whoops, no, that's not right. Go. No, am I going the wrong way? All right, here we go. Also notice how he's arranging all of these Skittles, I think is really interesting. All right, so the answer is not 812. What is the answer, and what accounts for the answer not being 812? Go ahead and put your answer in the chat to that question. What is the answer and what accounts for the answer not being 812? Yeah, very good. So obviously there are not the same number of Skittles in each bag. There's not 14 Skittles in each bag. Very nice job. So we know in the real world that there's not a consistent number of Skittles in each bag. And that's what makes it difficult for the students when they go through and they do that multiplication is obviously that they're essentially saying that there's the same number of Skittles in each bag. So it was the 14 Skittles times the number of bags that are there. So as they go through, they kind of figure that out. And so that adds a little bit of an interesting twist to this. But I love that there's that conversation, but also the way that he arranged this answer, which is in another array, and having students look at groups of 10 here. So I thought that was really interesting and just a great way to end this particular 3-act task, is to go through and kind of see how all of this looks. So this is an example of what a 3-act task looks like, essentially starting off with a video that has a problem inherent within it, a problem that can be answered with mathematics, going through asking mathematical questions that can help to solve that problem, solving that problem, finding the solution, and evaluating that solution. So one of the things that I want to look here is, what other questions could we investigate that you had? One of you asked about the jar, the capacity of the jar. You had asked about volume. We could turn this into looking at capacity. We could turn it into looking at volume to see, okay? There's a variety of different things that we could look at here. We could find the average number of Skittles per bag. We could change that. You had asked about if we were to look at, instead of using so many little bags, how many bags would we use if we use the larger bags? That would be an excellent investigation for students to do as well. So there's lots of ways that we could then extend this problem in new problems that students may want to think about. If they change the variety of Skittles, does that change the number of Skittles that are in each bag? Okay. Can students create a word problem for this equation? Absolutely. Lots of different things that students can do, even essentially, like Leslie is saying, with just that picture of that array. Can you take that, create a word problem, create a number sentence? Can you create an equation with this? That students can then extend that. So we love the opportunities that something like a 3-act test gives us to extend students' mathematical thinking, right? Now, when we think about 3-act math tests, I want you to consider these two problems, all right? And you can throw your thoughts in the chat also, but the problem that you have on the left is the Skittles problem. So that's the one that we just did. This essentially answers the a 4th grade standard that was multiplying two-digit numbers using graphical representations, area models, and I think it was partial products. And then on the right is literally the same standard I took out of a well-known, will not be named curriculum textbook. Okay. These are essentially the exact two same activities, okay, that students could do that teaches them the same exact thing. All right. So it was 4 NBT, I think it's 5 multiplication algorithms. I want you to think about the experience that students have doing these two problems. And I don't want you to think about like your typical math student. I want you to think about like all the math students that do math problems. Think about them, and then think about, and this is where it gets a little more thought-provoking, Think about the real world application. Which one of these problems would you consider more real world? And last but not least, which one would you consider more inquiry based? All right. So you can mull those around in your head. And chances are we won't all agree on everything because that very rarely happens in these conversations. But when you have some thoughts to share, go ahead and if you would be so kind to put those in the chat, or you're welcome to unmute and just share your thoughts. Where, we can also definitely just have a conversation. Completely up to you. But I'm interested in hearing your thoughts about the student experience of the 3-act task versus your traditional textbook problem that's on your right. Student experience, real world application, and then in terms of inquiry. Okay. So 3-act task, more inquiry based with what you notice and what you wonder. Very, very good. Okay. So when we think about inquiry, we typically do think about, encouraging students to make observations and then ask questions about what they observe. Typically with inquiry, those questions lead student investigations. 3-act tasks allow for students to have more math talk and hear others' responses to learn from one another. Okay, good. And math talk is good. We love to have students talking about math, especially in elementary school. Anytime I get the chance to have conversations with elementary math teachers, I cannot emphasize enough about letting kids talk about math and just making it a regular, everyday routine thing. Before the last probably 8 years, I've spent a lot of time in elementary and early childhood math. But before that time, I spent all my time in middle school math. And by the time that the kids got to me, they were so guarded about talking about math and being wrong. And it was so difficult to break them of that, just being so self-conscious about math. So that is very true. Just allowing them to talk about math and understand that there are so many different ways of seeing and understanding and viewing math. So that is very important and definitely goes with that 3-act task. Any other thoughts? What about applications of real world? Which one would you consider more real world? We spend so much time emphasizing that math needs to be real world for kids to be able to understand it and relate to it. There's always the kids don't like to do math because it doesn't apply to them. They don't see it it's not real world enough. What does that even mean? Like which one of these is more real world, would you say? Or relates more to a 4th grader's real world? Does anyone have any opinions on that? Yeah. So Kelly kind of commented that the one on the left was action and had color. Damn, yeah. Kids do relate to candy for sure, especially I have 3 children, and I'm embarrassed to say I feel like candy is one of their main food groups. Well, at least lately, it's bad. The one on the left was action and had color. Kids are visual in like videos, and that is very true. Now I'm going to change this. I'm gonna twist this into being more of a selling point here from an educational standpoint. It has action and it has color, okay? And kids are visual and they like videos. I'm going to change that and I'm going to warp that into, let's think about our kids and all of our kids. When we look at these 2 examples in the students that we are teaching math to, that have all kinds of different needs and come from all different kinds of places. When I look at the one on the right from the textbook, it has a very high level of literacy demands. There are a lot of words on that page. There are a lot of directions. There's a story problem. It's in one language. When I look at the problem on the left, it is in a video with no word. Well, I guess it says Skittles with virtually no words. There's no one giving directions. It is a video that's easy to follow and is visually interesting. When we think about the math, so if I was to place a math dial on these two different resources, the math dial on the 3-act task is very low. There's no numbers. There's no variables. There is a jar, but it's being filled with candy. When I look at the math dial of what's on the right in the textbook problem, the math dial it's cranked. It's pretty high. I see not only numbers, but those numbers are mixed in with letters in a word problem. And then I see not one template to put numbers into, but I see two. So two ways that I have to show my answer. And what happens if I don't know either of those strategies? Now I'm like really in trouble. Okay. So in terms of literacy and math from the beginning, they are very different. When I think about how students access these problems, we think about where the floor and where the ceiling is, right? So with the 3-act math task problem, these are what we call low floor, high ceiling problems. A student can enter this problem anywhere. They can simply make an observation. They can make an estimation. Like I said, estimations are cheap and easy. Anyone can do them. When I look at the textbook problem, there is not a lot of room here to access this problem if you don't even know where to start. This problem is nailed to the floor. If you can't read this problem, if you can't figure out what numbers to put in that box right there, we're in trouble. So when we think about the dynamics, even beyond the math, there is a huge difference between these things. Okay. So I think that those are some very valuable pieces to consider when we think about the resources that we use with students. Now, I don't want that to be misconstrued into textbooks are terrible and they should never be used. That's not what I'm saying at all. What I am saying is that there's always just a great opportunity to use different resources for different purposes. And I think that a 3-act math task is a great resource to use with lots of different students for lots of different reasons. So again, another tool to have in your toolbox for a variety of different ways. And I think that depending on the backgrounds and the cultures, relatable is relative. So yeah, I think that that's a good point. Okay. So when we think about real world also, and we think about the context that students are examining math problems in, I love this quote from Dan Meyer. And I think that this really speaks to what real world means for our students. And IMSA, I work at the Illinois Math and Science Academy. I don't even think I said that at the beginning, which I probably should have told you where I actually work. But anyway, the Illinois Math and Science Academy is actually a residential high school. And I don't work with the students there. We work in the outreach department, but it's really interesting to hear, all these thoughts on what real world is and how everybody views the teaching of mathematics differently. But I love this quote from Dan Meyer because I think it's so appropriate for thinking about what math should mean to students in terms of real world at any age. So he said, if you can ask questions about it, it's in your real world. If you can guess about it, it's in your real world. And if you're able to argue about it, it's in your real world. And I love this quote because I think it's so true to what real world means. So I have a 6-year-old daughter, and what is in her real world at this moment is very different than what's in my 65-year-old dad's real world. And what's in his real world and what he sees as math is very different than what is in her real world that she sees as math. But what is always consistent is if she can ask questions about it, and if she can make guesses or estimations about it, and if she's able to argue about it. So sometimes it's not about the content, but what it is about is what you are doing with it. And I think that that's really important. And I really like that. And I think that this quote right here really hits it on the head. That's what makes it real world to a student, is what they're doing with that information and that content and that mathematics. You want them to be asking questions, you want them to be guessing, okay? And you want them to be arguing. And people, there's always the argument that like, but if students aren't interested in it, and I think that that's a different conversation. Being real world versus like being interested in it is different. There's actually a book out, an article by, I'm going to make sure I get his name correct, Daniel Willingham. It's called Why Don't Students Like School? And he made a really interesting point that says that there are contexts like when often educators or whoever will change like math word problems, and they'll be like, okay, well, my kids are like really into like Nike shoes right now. So they change all word problems to like involve Nikes or Nike shoes or like whatever else kids are into. And it'll be like, well, now they're really going to want to solve these word problems. And they're just like dumbfounded when the kids will get through like the first two and then they're like, yeah, we're done. Even though like, but they're about the Nike shoes. And what Daniel Willingham says is the interest is in there, the content is in there that they're interested in, but the boredom of the math will always take over the interest of the Nike shoes. You can't disguise that the math by blanketing it in whatever the students are interested in. So there has to be a better way in order to engage them and keep them interested in the mathematics. So that's why something like these 3-act math tasks we encourage them to be used. They are a great resource, and they really touch upon these different types of things for the students. Okay. And it's the same thing with inquiry, where we have students asking questions, gathering information, evaluating it. What did we need? What don't we need? What conclusions did we arrive at? And where do we go next? What other questions can we ask about what we have? And inquiry is difficult to use sometimes in a mathematics classroom. We see it used a lot in science, but not so much in math. So we like that about the 3-act math test. They are very inquiry based. Okay, so we're going to spend our last 15 minutes kind of going through each of the acts and like really breaking them down and seeing what they look like. And then I'm going to show a quick video of a 3-act task being done by a wonderful math educator, Graham Fletcher, who I'm sure many of you are familiar with. He did a 3-act task in a kindergarten classroom. So you get to see some kindergarten kiddos going through one, which is like insanely adorable. But in the first act, all we are doing here is introducing the conflict. And this is typically through a video or a picture. Again, low floor, high interest image or visual that students are seeing here. They do noticings and wonderings, which again, if you have seen anything through NCTM lately, is a huge emphasis of excellent mathematical practices, having students make observations and ask questions. And then they engage in Goldilocks guessing. So we love Goldilocks guessing. That's the too low, too high, and just right. And I will tell you, as a previous middle school teacher, the more estimating your kids can do, the more middle school and high school teachers will love you, because middle school and high school kids come to math often and they have the most ridiculous, unreasonable answers, and they have no clue that they're ridiculous and unreasonable. And it's sad. So if you can have them estimating is quick, easy. In science, they spend so much time making predictions. And in math, it's the same thing. Making estimations is the same as making predictions in science, and we just cut it out for some reason. So I encourage you to make that a regular practice. And then obviously collecting data, inviting learners. And the second act, we ask them to think about information. So what do you need to solve that problem? What would you ask for? And with that is, and sometimes you don't get all that information. Sometimes in the world outside the classroom, we don't get answers to everything that we ask for. Sometimes we ask questions that can't be solved with mathematics. So we don't get that answer for that problem. But finding that information, putting it together, finding a problem-solving strategy that arrives at a solution, and messing around with that. Now, from an educator standpoint, if you're asking yourself the question, yeah, but when would I teach that? Now is the time. Students have a reason to learn how to multiply two-digit numbers. They really want to know how to multiply 58 times, 14. Okay, now is the time to teach them that. They're dying to know how many Skittles are in that jar. All right, so now is a great time to show them a variety of different strategies on how to do that. Okay, so that's, and this would kind of be like on the right side of the screen, you can see these boxes. This would be like, this is the student page for what this would, how you would fill this out. And that student page is in, you can download that when you download this presentation. It comes with it. Okay. All right, and then in the third act, this is where we solve, where we see the resolution, we evaluate our answer to make sure it is reasonable, go back to our estimation, and then we set up a sequel or an extension. What could we do next? What else does this make you wonder? Okay, it's important to remember this isn't where we stop. Getting an answer is not it's not it. The learning doesn't end here, so we can extend it. And, formalize the content is what we say here. Okay, so those are our 3 acts of the 3-act math task. All right, so I'm going to show you a little bit of this video just to kind of give you a sense of what this looks like with really young kids. This is called the Candyman 3-act task. I will show you at the very end of this a huge database of K-5th 3-act tasks where you literally just have to click. It shows you the standard in the main question. You just click and download the videos and the pictures, and it's all ready for you. You just throw it up on your board and you're ready to go. So I will share all that with you in here in a second, but here you can see what this actually looks like with a group of kids.
I want to show you this video, and I'm going to show it to you 2 times. I'm going to show it to you 2 times. Ready? So here's the first time. And the first time, I don't want you to talk to your partner. What I'd like for you to do is take what you see and put it inside your mind. So like, think about it. What do you notice when you watch this video? Ready? Here we go. Good job. I'm going to show it to you one more time. All right, here we go. All right, what I'd like for you to do right now is talk to the person that's next to you. What did you notice? Go ahead. I think they're called... They are. Is that chickle tabs, circle tabs? Okay, so we noticed some candy. Candy. What else did we notice? Yes, ma'am.
We noticed that you had slapped it out.
Oh, so that's my hand. Okay. I'm just going to put down Mr. F for Fletcher. That's Mr. Fletcher's hand. All right? Good, good. I like that notice. What did you notice?
I noticed it was a tooth.
It looked like a teeth. Okay, so it looks like we might have seen some teeth.
No tooth.
A tooth. Okay. A tooth. All right. What else? What else did we notice there? What else?
We saw him. We saw you turn the handle so it will make the penny go in, and then the candy comes out of it.
Oh, so you saw me turn the handle,
And then you pick the candy out.
and when I took the candy out, where did I keep the candy?
In your hand.
And what was my hand? Was it open? Was it?
Close.
It was closed. So what was inside my hand?
Bubble gum.
Candy. Awesome. I like the way you're waiting. Go ahead. Tell me what you noticed.
So the students go through and
You
they make
noticed
their,
a jar.
they
What was-
make their noticing, many of which you noticed are some are a little bit mathematical, some are what you would typically expect a kindergartner to say. Okay, but he writes them all down
All
because
right.
all
And what
student
did you notice?
observations
Last
are
one?
valid. Okay, and then of course he goes through and he
Candle.
also then
The
starts beginning to take
the
what
candy-
they wonder.
Colors.
Okay.
What do you wonder about?
I wonder how the money got in.
How did the money get in there? I love it. Okay, so how did the money get in there? Get in where?
The machine.
How did the money get in the machine? All right. Question mark. All right. What do you wonder?
It was kind of like an oval, and it looks like an oval, but when you put it in the hand, it looks like a square. And then when it came out, you had to stick it under it, take it out, and hold it.
And I held it like this. Okay, so I held the candy in my hand when I pulled it out. What did you notice? I mean, what did you wonder? Sorry, what did you wonder? What's a question that you have?
It's different colors, and it looks like.
And it what? What did you say?
So he continues on and asks them about what they wonder and what they notice and what they wonder, and they eventually get to the question. Obviously, how many pieces of candy is in his hands? For the second part of this act, this is the information that they get. So they are told that there are 4 pieces of orange candy, 2 yellows, 0 pinks, 2 reds, and 2 whites. And obviously with this information, they then have to go through and they have to determine how many pieces there are altogether. So to give you an idea of what this looks like through student work samples, here are 3 samples. Okay, so then again, this is from a kindergartner, right? So they draw pictures. We encourage the kids to draw pictures at this age and count. Some students are putting together actual number problems and adding. So a variety of different ways to show their work and understanding of these problems. Again, a typical low floor, high ceiling problem we love to see with the kids. So they go through and they're able to show their work and then of course explain it. And they go through and they get to see the final answer where the problem is revealed. Okay, so very fun, very interesting way for them to see all of the different pieces. Okay, now some ways for students to get started with this as we kind of wrap up for today. How do you begin encouraging students to do low floor, high ceiling problems that build up to 3-act math tasks? And where do you find these resources? Some very wonderful typical ones are Estimation 180. open middle, and which one doesn't belong, which I always love sharing with my math educators. These are wonderful resources that are free and out there for you to check out and consider. These are great for number talks, which develop the skills needed for for 3-act math tasks. So I'd encourage you to check those out and use them regularly in your math classes and your math routines. And here is your database. So when you go for my elementary teachers, Graham Fletcher, this gfletchy.com 3-act lessons, this is going to be like your mothership of 3-act tasks for K-5 teachers. And he has updated what this looks like just a little bit, but it will give you the lesson title, the standard, the big ideas, and then the question that they will be answering. And again, you collect all of their questions, but you have one in mind that you generally want them answering that relates to that standard. You'll also see down at the bottom are a variety of other math educators that create 3-act tasks, and they also have their own databases that you can check out as well. So this isn't something you have to create on your own time. There's plenty of free resources out there, and it is literally a download. Not complicated at all. We love to use them, and I encourage all of you to check it out. Very simple to use. Okay. Some examples, they have K2 ones that have to do with counting and cardinality, operations, number sense, algebraic thinking, geometry. These are all videos, very fun, simple to watch, simple to use, simple to download. So there's some of these. The 3rd through 5th grade have measurement and data, operations and algebraic thinking, number and operations. I think that's like the hot dog eating contest. Ugh. And there's even a good one for fractions, which who doesn't need more stuff to teach fractions? Even high school teachers could use some extra stuff to help teach fractions, I think. Okay, so lots of different resources out there. Oh my gosh, we're going to turn him off. That's gross. All right. Anybody have any questions about 3-act math tasks? Feel free to throw them into the chat. You see there's the link where you can download the presentation. The presentation also comes with the instructional pages for a 3-act math task in the student pages that you're welcome to check out as well. Okay. I think Kelly's going to go ahead and share that in the chat also.
Yep, I have placed in the chat. You will have the link to Lindsey's presentation, as well as an eval that she's asked to help her with IMSA's outreach.
Yeah.
And the thing that might be the easiest thing to do, I'll be on here, but if you just want to copy that right out of the chat, that might be the easiest thing. And so you'll have that. And this has been fantastic, Lindsey. Thank you so much for providing all of these resources and to give teachers an opportunity to actually go through what a 3-act math task actually feels like as kind of on the other side of being a student. And so just fantastic resources, whether it's Graham Fletcher or Dan Meyer, and there are others, but don't be afraid to start somewhere with some of those more math talk kind of building blocks that helps you maybe become more comfortable with doing these 3-act math tests. It's definitely going to make a difference with students and their motivation and their learning and their understanding. So thank you so much. Again, if you are an ICTM member, please make sure you check out. And if you have questions, you have Lindsey's email there on the screen as well as in the chat box. And I'll stick around. I'm going to stop recording this.